I've received a few emails from students regarding solving problems. The first problem I was asked to solve is one from the review question. So here is question 8. The numbers in red may change. If you notice, this is a product. We have this function here, and we have this function here. So keep in mind that if you're given a product, right? If given f of x is equal to the combination of two functions h of x times g of x, then f prime of x is equal to h prime of x times g of x plus h of x times g prime of x. So this here is the rule, okay? It's the product rule. So in our example, or in your example, what's given to you, f of t is equal to 5t to the 6 times cosine of t. So what I'm going to do to clarify this, I'm going to call this here, this function h of x, and I'm going to call this function g of x. Okay, so h of x is equal to 5t to the 6. So h prime of x would be 30t to the 5th. In addition, okay, in addition, g of x is given as cosine of t. So g prime, g of t, I keep writing x. So we need to change this. All of these have to be t's. H of t, h prime of t, g of t, g prime of t, and the derivative of cosine of t is minus sine of t. So back to this now, we know that f prime of t would be equal to h prime of x times g of x plus h of x times g prime of x. So let's just plug in. Instead of h prime, I'm going to write this here. So that becomes 30t to the 5th. And then we have g of x. G of x is, or g of t, okay, all of these supposed to be a function if t is there. So let me change them and write the t's. I keep writing x's. So this will be h prime of t times g of t plus h of t times g prime of t. I need to write everything in terms of t. H of t we had called this, and this is g of t. It's a constant habit that we use x a lot. So h prime is this, g of t we know is cosine of t, plus h of t is here, so that's 5t to the 6 times g prime of t is here, which is minus sine of t. Simplifying, we have 30t to the 5th cosine t. The plus, when multiplied with a minus, becomes a minus 5t to the 6th sine of t. And that will be f prime of t. Yeah. One problem that was sent to me was question 6, where you're given the position function. Okay, position function. So given the position function, position function given was s of t is equal to minus 16t squared plus v0 of t plus s0. Okay. Your function, the t wasn't in parentheses, so I'll leave it as. Now, in the position function, okay, the v of 0 here is the velocity at 0, and s0 is the position at time 0. Okay. Now, if you look at your problem, so this here, okay, this was given to you. It's over here, position function. Now, if you continue to read the second line, they told you that a ball is thrown straight down from the top of a building, okay, of 800 feet. So that means when the time is 0, you're 800 feet in the air. So S0 is equal to 800 feet. Okay? It's telling you that you're on top of a building. Okay? Let's say this is the building, that's the street. This building's height is 800 feet. So you're over here. This is you. When you drop the ball at time 0, t is equal to 0. That ball, the distance s is equal to 800. As t becomes, let's say, 2 seconds, that s will reduce because the ball is falling. Ball is falling. And the initial velocity given to you, the initial velocity was given to be minus 30. So that means that v0 is minus 30 feet. Okay. So therefore, if I plug these into here, okay, actually, that may be neat. If I plug those in, S0 here and V0 over there, we have S of t is minus 16t squared, V0, so plus a negative 30, that's V0, t plus S0 is 800. So S of t is equal to minus 16t squared. These two becomes negative 30t plus 800. And that would be the position function. S of t is the position function. Now, in my notes, you will see if you have S of t, okay, the position function, and you take S prime of t, okay, the first derivative, this is called the velocity function. So by taking the first derivative of S of t, you will get V of t. Well, S of t is given to you, well, we found it, minus 16t squared minus 30t plus 800, okay? So S prime of t, which is the same as V of t, will be equal to minus 32t minus 30 plus 0, right? Constant derivative will be 0. So V of t is equal to minus 32t minus 30. There is no need to write plus 0. And that is my velocity function. So right now, we found two things. We have S of t, which is minus 16t squared minus 30t plus 800. we also have v of t is equal to minus 32 t minus 30. So far, if you look at the problem, we have done part A, checked. Part B, determine the average velocity in feet per second on the interval 1, 5. Okay, so if you look back at your notes that was posted in the video, there is a formula for average velocity. So if you're checking your notes, or we don't even really need to know the formula, right? You don't really need to memorize any form because you know what velocity is. Okay. So we have the distance, or the position function s of t. S of t is minus 16t squared minus 30t plus 800. And we know that the velocity is the change in speed over the change in time. Okay. The average velocity is equal to the change in delta, the change in the position over the change in time. Okay. So you're in an interval 1, 5. So what is the distance we need? What is s of 1? Well, s of 1 will be minus 16 times 1 squared minus 30 times 1 plus 800. And that is equal to negative 16 minus 30 plus 800. Okay, which is equal to minus 46 plus 800. And minus 46 plus 800 will be positive 754. Okay, now what is s of our interval is 5 after 5 seconds. So after 5, we have minus 16 times 5 squared, right? We're using the position function. Minus 30 times 5 plus 800. So this becomes minus 16 times 25 minus 30 times 5 plus 800. And negative 16 times 25, that becomes negative 400. And this becomes minus 150 plus 800. So minus 400 minus 150 plus 800, that becomes 250. And it makes sense, right? Notice that the distance is decreased, or has decreased, because remember, you're on top of the building, right? Here is your building. The building is 800 feet. After 1 second, that ball has dropped. At t equal 1, the height is 754. Okay, that's your height. At 5 seconds, okay, when t is 5, okay, now s is equal to 250. Okay, so we said that the average velocity is equal to the change in s over the change in time. So this becomes the change in s over the change in time. We'll just plug in. Okay, so if we plug in numbers, this becomes 250 minus 754 divided by 5 minus 1, which is 250 minus 754. That becomes minus 504 over 4. And if you do the division, that becomes 126. Now be careful, if you look back at the problem, okay, if you look at your problem, it's asking you for the average velocity. And remember, when you did this units here is feet, and this units here is seconds. Okay, so the answer has to be feet per second. Now it's going to be negative. This negative here implies that it's moving downward. Okay, that negative implies it's moving downward. So if we move on to part C, so we're done with part B here. For part C, you're asked to find the instantaneous velocities. First, you were finding average velocity. Okay, now you're asking for instantaneous velocity. So to find the instantaneous velocity for part C, we use the function v of t. Okay, instantaneous velocity. So v of t, when we found it, was or is minus 32t minus 30. Minus 32t minus 30. And your question is asking you for v of 1 and v of 5. Okay? When t is equal to 1 and t is equal to 5. Well, if you have v of t, you can find v of 1. V of 1 will be minus 32, okay, times 1 minus 30. So this becomes minus 32 minus 30, which is minus 62. Okay, minus 62. Now, if you look at the question once again, it's asking you for the instantaneous velocity, okay, meaning the speed of the motion of it. So that will be feet per seconds also. Okay, instantaneous velocity, feet per second. And then v of 5, I believe they ask you for. Go back and look at it. Too much scrolling back and forth. V of 5, yes. V of 5 would be minus 32 times 5 minus 30. So v of 5 will be equal to minus 32 times 5. That becomes negative 160 minus 30. So v of 5 is equal to minus 190 feet per second. This is v of 1. Okay. Those are your instantaneous velocity. So we're finished now with part C. Now part D and part E are very straightforward. You just have to understand. It says find time, okay, for the ball reach the ground. So remember, you have your position function. Your position function is this function here. So they want you to find t when s of t reaches the ground, meaning that height is 0. If we go back and look, when the ball, this ball reaches the ground, s is equal to s of some time is equal to 0. And you want to take how long that ball travel before it reached the ground. So we have, this is part D now, part D, okay, part D, S of t is minus 16t squared minus 30t plus 800. So because the ball reached the ground, S of t is equal to 0 when the ball hits the ground. So minus 16t squared, 0 is equal to that, is minus 30t plus 800. Now this is quadratic. Okay, so minus 16t squared minus 30t plus 800 equal to 0. You should be able to solve this. Now be very careful. You are solving for time. So time must be greater than or equal to 0. If you happen to get a negative value for time, you will have to throw it out. Okay, so I'm sure you could solve quadratic. Now for part E, you have to find, in part E, find the velocity in feet per second at impact. Now you know, after you solve the answer for this part here, you're gonna have some time, okay? T will be equal to 2 values because it is squared, and T will be equal to a second value, okay? Value T should be 6.195 rounded to 3 decimal place seconds, okay? Now you have for part E, find the velocity for part E. We're looking at part E. V of t you have. We found the v of t, the velocity function is minus 32t minus 30 in part C. Minus 32t minus 30. Now, when the ball hit the ground, t is this number here. So v of 6.195 will be minus 32 times 6.195 minus 30. And v of that number, okay, v of that number, 6.195, should be approximately equal to, the answer was shown, minus 228.3 to 1 decimal place. Minus 228.3. Minus 228.3, okay, feet per second. Okay, when you plug that in, you will get that. And that's the answer for part E. Okay. So I was asked to look at this problem also, right? Use the product rule. So y is equal to 4x cosine x minus 4 sine x. So if you're asked to y prime, what I'm going to do, I think you guys, I would strongly recommend, these are two functions. Here we have one, it's the product. Here we have another, okay? Here we have one. Here we have another, okay? So y prime, if I call this here h of x, I call this g of x, if I call this p of x, and I call this t of x, okay? Y prime will be h prime of x times g of x plus h of x times g prime of x. That will be for this part here. Minus, and don't forget, because of this minus, now all of this quantity, so be very careful. P prime of x times t of x plus p of x, p prime of x, p of x times t prime of x. So why don't we figure out what these things are? H of x is equal to 4x. Okay, let's write it in the corner. H of x is equal to 4x. So h prime of x is equal to 4. Okay, g of x is equal to cosine of x. So g prime of x is equal to minus sine of x. Okay, p of x is equal to 4. So p prime of x is equal to 0. T of x is equal to sine of x. So t prime of x will be cosine of x. And then let's fill in each one of these things over here. Okay, and that's what I'm going to do now. So y prime is equal to h prime, we have 4. g of x we know is cosine x, plus h of x we know is 4x, right? H of x. G prime we know is minus sine x, okay? Minus, bracket now, p prime is 0, t of x is sine of x, plus p is 4, and t prime of x, we found that is cosine of x, okay? Cosine of x. So if we simplify, obviously this is going to go away to 0. This becomes 4 cosine x plus 4. Well, this, when you multiply this minus and this plus, so this becomes a minus, okay? 4x sine x. And then when you distribute this negative, this becomes a minus 4 cosine x. So now this will be able to cancel with that. So y prime is equal to negative 4x sine of x. Okay, that will be the fourth. So I hope these explanation was clear. Those are some problems I saw in my email that was asked to solve. Okay, I'm gonna now send this out to you guys. Thank you.